Okay, this presenting is recorded. Alright. Minggu lepas kita ada cover pasal set sikit ya. And we already know, actually you already know some of it because of the previous lesson. And also from this is a basics, right? Set. Set is a collection of elements. And then I also iterate that you have two types of notation. The first one is roster, where you list down all the possible elements. And then you have a set builder notation, where you define the variable and you define the predicates of the variable or the characteristic of the variable. That is the common way of represent the set. So Venn diagram dah equal, sudah juga. Subset saya lebih sikit hari tu. Dan kita hari tu di sini ada sikit cardinality of the set. Dan saya juga dah buat beberapa perkara, iaitu test you guys dengan apa tu, how to count the set. The cardinality of the set, make sure that you, when you count the number of element of the set, the number of distinct element of the set. So if the element repeats itself, I'm sorry. Okay. Cardinality of the set, the element must be distinct, and it means that if you have a repeated elements, you only count as one. Itu yang penting. Set is not necessarily in order, but when you count the element, it must be distinct. If the element repeats many times, you only count as one. Okay, itu paling simple. And because the empty set, okay, question posted by your friend. Actually, it's a good question. Where Tengman asked me about the cardinality of empty set. Okay. Empty set. This is empty set. Okay. This is not empty set. Definitely. Different. It is different. How you represent empty set? Ini adalah empty set atau ini empty set? You have nothing inside, or this is a special notation. So this particular example of set A is actually empty set. This is not empty set. Alright, because on how you represent the set, set dia ada dalam curly bracket. So untuk set B ni, dalam curly bracket ni, dalam ni adalah simbol empty set. So set B is actually not empty. So if I want to find the cardinality of A, of course it's 0. However for B, it's 1. Kalau korang tengok betul-betul, those A and B is memang, it's totally different representation. Okay, kalau saya ada satu lagi C, set C, ini lagi tak empty. Ini lagi clear lah. Okay, so what is the cardinality of C? Although it contains the element of empty set symbol, but actually C is not empty as well. C is 2. Okay. Oh no. C bukan 2, betul? Yang ni kalau kau kira, dia ada sama elemen, so dia adalah 1. Because it repeats itself and it's the same, so actually it's 1. Ni menarik, saya tak pernah tanya soalan ni. So banyak budak akan salah kalau saya tanya ni. C contains two elements and the element apparently is the same, it's not distinct, therefore C is actually 1. Alright. Union, it's very simple. I think I want to discuss a little bit on the difference of set first. Yang lain boleh baca sendiri, addition of set nanti dulu, difference of set. Alright. So pay attention please. Alright. Sebab selalu ini saya ajar dalam kelas, saya tak tunjuk semuanya dalam slide. Okay. Suppose A, I define as a very simple one. If I put 1, 2, 3, 4, 5. Okay. And B, let it be prime number. Tak cukup. Boleh lah. 2, 3, 5, 7. Okay. Okay, A contains this 1, 2, 3, 4, 5 and B contains prime number until 7. Okay. So what is A minus B? Okay. By the definition of difference of set, it means that elements in A but not in B. A minus B is the element which exists uniquely to A but not in B. You can read the notation like this. X is an element of X. X contains in A, but X is not an element in B. And the Venn diagram on the left clearly shows that it only exists uniquely to A. So it means that if there are elements that coexist both in A and B, that one does not count because it is still contained in A. So to find the solution for this, A minus B, apakah elemen yang hanya unik kepada A, tidak kepada B? 1 and also 4. You try to also look at for A case. Elemen apa yang hanya unik kepada A? Iaitu 1 and 4. 2 is in B, 3 is in B, 5 is in B. So you don't need to write that on the A minus B. There is one approach. One more approach is that I always explain to the students, you can also do it like this first. Okay, ni clear. Ada setengah student nampak direct. Saya tak ada isu kalau ada student boleh nampak ni direct. Tetapi ada setengah student yang dia tak boleh nampak dengan cara ni. Saya akan buat pelan-pelan. Saya cakap kepada mereka, why not find A intersect B first? In A intersect B is 2, 3, 5. Okay. So A minus B is you list down all the element in A first. Later, eliminate the thing which is coexist in B. So dapatlah 1 and 4. Okay. Ini untuk student yang tak nampak. Kadang-kadang bila saya nak ajar student, saya kena guna pelbagai cara. Ini based on my previous experience, some student cannot see this directly. So what will be? Okay, ni settle lah. Saya nak test kamu sekejap sebelum saya buka kepada soalan. Soalan lain. Find B minus A. Apakah jawapan dia?
7.
7 saja ke? 7 saja ke?
Betul.
Betul.
Ha.
Very good. Memang senang. B minus A is the element that is uniquely exists for B but not in A. You can both use either way. Sama ada kamu nak tolak terus atau kamu kalau tak nampak, kamu buat dulu A intersection B, then you write down B, then you cancel out A intersect B or you cancel out A directly. So jawapan dia memang 7 sahaja. Nanti kita buat lagi latihan. Ada soalan berkenaan perkara ni, A difference B. Saya tengok chat jap. Dah record dah. Dah record. Alright. Ada soalan lain? Sekejap saya tengok. Takut ada soalan. Alright. This is very direct. Untuk for this example. And of course, in some of the questions, sometimes I write A and B in the set builder notation first. That inquires you to list down all the element in roster notation, then you couldn't do the operation. Also exists that kind of question. Yang ni direct lah, saya terus tulis roster notation. So you bila tolak tu boleh nampak lah. While you have this idea of A minus B, why not I directly tell you about the symmetric difference or mutually exclusive. Ini benda baru. Saya rasa kat sekolah tak belajar. Tetapi konsep asas dia ialah A mutually exclusive B. This is the symbol. First of all, A mutually exclusive B is also equal with this B mutually exclusive A. It is both direction. A minus B, macam kau orang tengok tadi, A minus B is not equal to B minus A for that particular example. But for this case, A mutually exclusive B is actually equal to B mutually exclusive A. Because A mutually exclusive B, it happens in both ways. A minus B union with B minus A. Alright. So you manage to find A minus B first, and then you need to find B minus A, you union with them. So for the previous example just now, A is given as 1, 2, 3, 4, and 5. And B is a 2, 3, 5, and 7, right? If I want to do this step by step, I need to do A minus B first. Okay, so A minus B is 2, 5 just now, 1, 5, 1, 4. What is B minus A? Is 7. So A mutually exclusive B is 1, 4. Alah, 3 pula. 1, 4 union with 7. So the outcome at the end will be 1, 4, 7. The notion of A mutually exclusive B in the layman term is that they try to find the element which exists uniquely to either A or either B. Unique to A and B, but not both. So this is one of the way to get it. You try to find A minus B, and then you B minus A, and then you union both of them. This is quite direct. And it's important for you, students, when you try to present your answer, it's better for you to do step by step. Ada setengah soalan kan, memerlukan untuk student tu tengok step by step. Kalau yang ni cantik lah, nampaklah jalan kerja dia. Cikgu kamu pernah kata, Dr. Zana pun pernah kata, saya pun pernah kata, kamu kena tunjuk, kalau boleh, lebih baik kamu tunjuk step by step, baru saya tengok, oh student yang jawab begini dia faham. Ada setengah student yang boleh lompat, saya kena nilai sama ada betul tak dia faham. My point is like this, imagine there is a student, okay, katakan ada student, dia tak buat jalan kerja, dia tulis 147. Saya pernah jumpa student macam ni. So, saya kadang-kadang nak devise soalan, saya kena buat dia supaya tak boleh direct dapat macam ni. Sebab tu kadang-kadang saya tukar soalan saya set builder notation dulu. Kalau set builder notation, tiba-tiba dapat ni. Dia tak tunjuk pun apa roster notation. Jadi pelik lah. So, andaian saya sama ada memang dia buat sendiri atau dia copy answer ni daripada orang. Itu yang bahaya tu. So, kalau boleh dalam zaman area online ni, kalau boleh tunjukkan jalan kerja kamu. How you to get the answer. Penting untuk kamu tunjuk. Okay. Sebab kalau kamu tak tunjuk, dia macam mana kamu dapat 147 ni? Macam saya nak tunjuk kepada kamu, saya tunjuk step by step. Baru kamu nampak macam mana saya dapat 147 ni. Alright, cara kedua, okay, untuk mendapatkan 147, for some of the student who cannot understand A minus B union B minus A, saya offer satu lagi cara saya. Alright, saya cakap kepada mereka, saya konsisten dengan A minus B tadi. I said to them, why not you can try to find A intersect B first, because A intersect B, most of the student, almost all student can find A intersect B very fast. Common thing memang dia orang nampak cepat kat sini adalah 2, 3 dan juga 5. Okay. So A mutually exclusive B, I said to them, write both A and B. 1, 2, 3, 4, 5, 2, 3, 5, 7. And then by using A intersect B as your reference, cancel it. Cancel it, and they are left with 1, ada 4, 7. Okay, you don't need to do both ways. Saya offer kaedah lain sebab saya tak tahulah, ada setengah student dia tak nampak ni, saya offer lah ni. Mereka not surprisingly, minority of them follow this way sebab dia nampak. So terpulang, kalau kamu ada cara sendiri yang buat kamu nampak, gunakan. Kaedah is kaedah. Yang penting jawapan yang akhir mesti sama dan saya tunjuk step by step saya. Memang dia buat macam ni. Dia cancel betul-betul follow saya. Especially student yang sedikit lemah, mereka guna cara yang kedua. Okay, that is about symmetric difference. Okay, Cartesian product nanti. Saya nak tunjuk soalan quiz lepas-lepas. Ini dia. Cuba jawab soalan nombor 2. Nanti kita bincang. Ni soalan 2 ni. Ni soalan quiz lepas-lepas. Saya tak ingat tahun bila. You should be able right now to state A and B in a roster notation. You should be able to do minus right now, and then you determine the cardinality of A union B complement. Complement. Okay, cuba jawab dalam masa sampai 5 minit. Cuba jawab, and then if possible, I want for the students to show me the answer. C ni ramai orang selalu silap. A minus B ni saya sengih je lah. Semua boleh jawab lah selalunya. But don't take for granted question A. Boleh cuba jawab sekarang. Because question A, if the student don't read the set builder notation carefully, then they will be wrong. A and B is always in U, a universal set. So don't write more than universal set. Thank you. Carry on. Saya turn on. Okay, ada yang dah dapat jawab. Thank you Musin, Devina and also Shaza because sharing the answer. So let's take a look. Okay, saya tak ingat jawapan dia. Biar saya tengok balik. Thank you Aizat Haikal. Okay, enough first. Bukan saya tak bagi dah. Bagi. Tapi saya harap jawapan sama. Kita refer. Yang lain simpan dulu. Alright. Sekejap saya tengok. Okay, Musin jawab 1, 2, 3, 4, 5, 6. Okay. It's a multiple of 3. 3, 6. Oh man. Okay, 369 tak nampak kecil dia tu. Alright. So A minus B should be 1, 2, 4, 5. Yeah, correct. And the cardinality of A, okay, union B. A union B is 1, 2, 3, 4, 5, 6, 9. And the complement will be 7, 8, 10. Okay, Musin, kamu kena bagi tahu cardinality dia tu berapa. Tak cukup lagi tu. Saya tak nampak jawapan kamu. Tak cukup. You should tell me the cardinality. Berapakah elemen kat dalam? So like okay, Devina did it completely. Devina dia siap tulis the cardinality of A union B complement is 3. So Devina lengkap jawapannya. Dan sama juga dengan Shaza, I suppose betul kat atas tu. Saya tak check dia punya roster notation, but however the N is correct. And Aizat Haikal siap lukis Venn diagram, which is good to enhance the students confirmation of the representation. Cantik. Dan okay, betul. Aizat Haikal, Shaza dan juga Devina, saya rasa betul jawapan mereka. Saya tengok seimbah lalu lah. Saya tak check betul-betul. Saya akan check banyak kali dan setakat check yang kali pertama ni mereka betul ketiga-tiga. Musin hilang 1 markah je. Okay? So it's good. It shows that the student understand the concept of minus and also the symmetric difference. Saya tak tanyalah kat sini. Saya akan cuba buat untuk kamu berdasarkan jawapan yang diberikan oleh kawan kamu semua, Musin semua. Saya nak buat ni untuk kamu. Saya nak cuba buat roster notation. Biar saya salin dulu apakah elemen A dia. And so B 369. Okay. Alamak. Alright. By referring to the same question, I want to show you what is B mutually exclusive A. The cardinality of B mutually exclusive A. Okay, soalan yang lain tapi hampir sama. Menggunakan A equals to 1, 2, 3, 4, 5, 6. And also I got B, which is 369. What is B symmetric difference with A? So tadi ada Musin punya jawapan, saya tengok A minus B tadi. A minus B ialah 1, 2, 3, 1, 2, 4, 5. Okay, what is B minus A? It will be 9. So B mutually exclusive A equals to 1, 2, 4, 5 and also 9. And if it has a symbol cardinality, we should complete it until we count how many distinct elements in the previous step. 1, 2, 3, 4, 5. Ada 5. Remember, B symmetric difference A is equal to A symmetric difference B. It happens in both ways. Okay, ada soalan setakat ini? Kalau ada boleh nyatakan. Ni soalan kuis yang betul-betul ni. DMA tahun bila saya tak ingat ni. Okay. Alright. We take a short break for 3 minutes, okay? Before we proceed to Cartesian Product. So, boleh cuci muka kejap. Hafiz Hakimi berkata B minus A number in B but not number in A. Betul. Kalau B minus A kau buat B intersect A, lepas tuliskan B, lepas tu eliminate yang sama antara B. Musim tertilap tulis kot. Yang lepas tu eliminate yang sama antara B dengan B intersect A. Okay, betul. Bagus. Tak apa. Kita kalau tersilap itu normal, kita betulkan. Kita betulkan sama-sama. I like this kind of attitude. Really? Kita nak sama-sama naik. Siapa punya ayat? Sama-sama naik. Okay, while we are having a short break, I just want to mention that actually there are some of your senior, your senior actually, and the other senior from the other faculty, they actually are here in UMP Gambang or either in Pekan. Last Thursday, I managed to have a small chat with my previous student from the MA subject because saya nak tanyalah, seronok tak duduk kat Pekan? Even I pun tak suka duduk kat UMP Pekan, hostel. Susah nak cari makan dengan zaman sekarang ni, tak ada orang sangat. And then dia directly post a picture of her celebrating the birthday with his friends. Birthday party untuk kawan dia. Waktu tu malam lah, saya saja chat dengan dia. Saya tanya, sihat tak? Seronok tak duduk sana? Do you have any problem? Sebab dulu dia takut nak pergi kat UMP Pekan tu. So dia kata, Dia tak kata apa-apa, dia balas balik gambar tu. Very simple gesture. You're showing that she and and her friends are very happy there. Boleh celebrate birthday of that particular, that boy's birthday also is my previous students. They are very happy. Terus hilang masalah saya hari tu. Bila saya tengok dia orang happy. Apparently they are doing just fine. Budak final year. Pergi pekan memancing. Ada ikan. Wah. Oh yeah, correct. So yeah, there are actually a tournament of fishing there. So later when all of this COVID thing finish, you can go there fishing. The actual fish, Hafiz Hakimi, ingat ikan betul lah. Bukan ikan yang anak ikan. No. Puding diraja kat sini pun ada. What I want to tell you the most is that this pandemic give many. Just now I relate with the mental problem posed by your UMP students in the UMP convention, and there are also students who try to think this positively and be happy all the time. Student yang saya cerita tu, dia sangat happy. Saya nampak dia senyum every time saya dijumpa saya. And she is one of the student that I admire. Kadang-kadang kita inspired by the students. Not the lecturer inspired the students. Sometimes we inspire each other. Student tu antara yang very inspiring kepada saya. Up until today. Saya ajar di 1 sem je. Tapi masih boleh berhubung sampai sekarang lah. Student yang boleh pass graduate dari UMP ramai. Student yang pandai ramai. Tapi student yang baik, ni macam saya memancing ikan kerapu dalam tasik air tawar. Kau tahu kan ikan kerapu apa kan? Tak tahu pergi basah ikan kerapu. Sungkingnya patut tahu ikan kerapu apa Garupa. So student yang saya main tu memang student yang baik lah. Okay. Can we continue back a little bit on Cartesian product? Okay, Cartesian product is new, but don't bother about the complex definition, because what you will learn is only for the 2 tuple. Imagine you have, saya clear Thomas. Ni definition ni Dr. Syam yang buat, so dia dalam sikit lah. Saya suka explain senang. Alamak, mana hilang benda-benda saya ni? Okay, pay attention in the class first. I need to update slide again. Saya tak tahu mana pergi. Alright, to put it in a simple matter, Cartesian product, okay, A, 1, 2, 3, 4, 5 ya, and B, 2, 3, 5, and also 7. The same element from the previous one. Saya tutuplah nota ni kejap nak bagi nampak luas. Okay, what is this operation? A, Cartesian product B. This particular symbol, if it involves set, is not a simple multiplication. It is called a Cartesian product. Product tu multiplication lah kan? Product. Okay, so A times B is a collection of one element from A, you pair it with B. Hence the name ordered pair. Kalau kita ada 2 set, we call it pair. If you have 3 sets, you call it triplets.
Okay, if you have 4 sets, then you name quadruplets and so on. So as it involves only 2 sets, it's very simple actually, Cartesian product. You take one element from A, you pair it with an element of B, 2. And that's not all. You must 2, 2. 3, 2. 4, 2. 5, 2. Okay, ada lagi. Kita dah selesai ni. 1, 3. 2, 3. 3, 3. 4, 3. 5, 3. Okay, so this example is a little bit long. So the thing is right now, you need to pair every element. So you can see there's a little bit of function there. You try to assign every element here. So A times B, number of element inside there, the cardinality will be represented by the cardinality of A times cardinality of B. Cardinality of A is 5. Cardinality of B is 4. So I should have 20 ordered pairs. Okay, that's why I said this example might be a little bit long for you to see. I will change the example afterwards. So right now, I only write 10. There are 10 more. Okay, this is the idea. First, the notion of A times B is you try to pair down the element you take from A, you take element from B. Okay, itu idea dia. Dan cara kita nak tahu berapa elemen kat dalam tu, A times B is equal to the cardinality of A times B, and I happen to have 20 distinct ordered pairs. Kena berbeza. Okay, saya tunjuk sekejap. Contoh yang pendek. Let me cut it short to A, 1, 2, 3. And B, let it be 3, 7. Boleh Pendek je. Okay. Depends on the question. But right now, how many ordered pairs that I will have? If I ask you, find A times B. Okay. A times B should have 3 times 2, it will be 6. 6 ordered pairs. 6 distinct ordered pairs. So if I want to find A times B, the elements on the left here should comes from A. Ni patut datang dari A. Yang second element patut datang daripada B. So I take 1, 3. Okay, ambil 1, 3. Lepas tu, you boleh juga ambil 1, 7. You proceed with 2, 3, 2, 7. And then 3, 3, 3, 7. 1, 2, 3, 4, 5, and 6. All of them are distinct. Pertama sekali, check for the distinct part and make sure the element here is from A. Element on the right of the ordered pair is from B. Itu penting. Why is that important? Because B times A is not the same. It's not necessarily the same with A times B. It can be only same when A equals to B. But right now it's not. So B times A, the same A and B, the first element should comes from B. So B apa dulu? 3. A datang 1. So 3, 1. You look this in the reverse part. 3, 1. 3, 2. 3, 3. 7, 1. And 7, 2. 7, 3. As you can observe here, A times B is not similar with B times A. And of course, the cardinality is the same. Because B times A, kalau kita letak dalam formula, adalah 2 kali 3, because these are commutatively. Cartesian product is also like a normal product, is commutative. So A times B equals to B times A, as exhibited by this simple example here. But the order is different. Yang ni 1, 3. 1 comes from A, B, 3 comes from B. For this one, dia terbalik. The first element comes from 3 and the second one from A. And the Cartesian product can also happens at the same set. It means like this. Find B times B. So you just do the operation on B. Can you do that? Berapakah distinct ordered pair dekat dalam?
3,
3,
3, 7, 7.
7, 7. You should have 4 distinct ordered pairs. Jangan lupa. Kalau musim itu saya tak apa, saya tak tengok, tak apa. Kalau kadang-kadang kita susah nak nampak, kita tulis balik. Okay, untuk kes ni 37 times 37. Boleh je buat macam ni. You 33 37 73 77. Dapatlah jawapan dia. Okay? Okay, take some time to digest the concept of Cartesian product. And I also like to repeat again, to ensure that your answer is correct, make sure the order A times B, kalau A times B, first element dalam ordered pairs is from A, the second one is from B, and vice versa. Kalau B times A, the first element in the ordered pairs is 3, datang daripada B, the second datang daripada A. The second thing that you must be careful about is that the number of element must be complete. And how do you know that? By the concept of cardinality. For this particular example, you should have 6 distinct ordered pairs. If you write multiple ordered pairs, then it will still count as 1. B times B, ada berapa? Cukup ke elemen saya ni?
Cukup.
Cukup. Sebab 2 kali
2, 4.
4. Paling cukup, paling minimum 4, and make sure it is distinct. Alright. Let's move on to a more kata complex example. A, I put 1, 2, 3. B, I put 3, 7. And C, I put X, Y tiba-tiba. Okay. There are 3 sets. So let's try to find A times B and times C. Okay, right now we involve 3 sets. And if 3 sets, the outcome will be the ordered triplets. Ordered triplets, bentuk asas dia. Okay, for the first ordered triplets, I should imagine there will be 3 elements from my ordered triplets. And the basis of this, the first, it will be from A, it will be from B, it will be from C. It must be in this particular order. You cannot change the order. The first element datang daripada A, B, and the last one from C. The answer will be quite long, by the way. Tetapi untuk orang kata tahu berapakah elemen kat dalam tu, you can get the picture. It will be A times cardinality of B times cardinality of C. So it will be 3 times 2 times 2. It will be 12. So should have 12 distinct ordered triplets that I will try to put the answer here. This is quite intuitive, tapi kena hati-hati. 1, 3, X. 1, 3, Y. And then 2, 3, X. 2, 3, Y. 3, 3, X. And 3, 3, Y. Okay. Before I proceed furthermore, as you can observe, this one comes from A, again, this one comes from B, and this one definitely from C. It means that if you write it wrongly like this, 3, 1, X, dah salah. Because there is no 1 from B. 3 mungkin ada, tapi 1 tak ada. So make sure you be careful on that mistake. Okay, saya undo. Okay, I just managed 6. I need 6 more. So saya dah habis 13X. Saya buat 17X, 17Y, 27X, 27Y. Close the bracket. So right now I have 12 distinct ordered triplets. And maybe some of you might ask like this, boleh tak kalau saya buat macam ni? Dia orang cakap, dia orang tak nak buat 13X, 13Y. Dia nak mulakan dengan macam ini. Dia nampak macam ni. 13X, dia nak buat 23X. And then 33X. Boleh tak dia cari saya? Dia nampak macam ni. 1, 3X, 2, 3X, and 3, 3X. And then dia nampak 1, saya pening kat macam ni sebab saya tak suka order macam ni. Tapi tak apa, saya layan je. 1, 3X, 1, 3Y. Okay, dia buat 1, 3Y, 2, 3Y, 3, 3Y. If you get my idea, what I want to point, that I want to say is here, dia akan dapat jawapan akhirnya sama dengan saya at the end. Because the set might not necessarily be in order. Okay. Maksud saya kat sini, saya mulakan dengan 13X dan saya tulis 13Y. Student ni dia mulakan dengan 13X, 13Y dia datang kemudian. Kalau kamu nampak ni di position nombor 1, ni di position nombor 2, ni di position 1, dia keluarkan yang ni nombor 4. In this context, the order, susunan order hanyalah dalam bracket tersebut, bukannya dekat elemen di luar. Saya ulang. Definition set, the element might not be in order. Dalam kes ni, elemen kita adalah ordered triplets. It means the outcome of A times B, ordered triplets ni, tak semestinya ikut susunan. Yang ikut susunan, the thing that is follows in order is what in the ordered triplet. Dalam ni yang kena ikut order. Tetapi kalau 13X datang kat belakang, dulu pun, that's fine. Jangan confuse the concept of ordered pairs, ordered triplets dengan element. Element dalam set tak perlu dalam order. Tetapi dalam bracket, which is in the triplets or in the pairs, it must be from the order. Okay. Saya relax je. Okay, do you have any question for the time being? Okay, kalau tiada saya nak uji kamu sedikit pengetahuan kamu. Alright. Abaikan soalan nombor 1. Nombor 1 dia true and false. Abaikan dulu. Apa yang saya nak sekarang ni, question 2 ni, saya nak kamu cari find sebab korang dah buat kan, apakah dia A dengan B dia, so tak ada masalah lah, boleh teruskan. Tapi saya tertarik adakah kamu dapat menghasilkan A times B. Nombor 2 ialah B times A times B. Saya tahu jawapan dia panjang, tapi saya nak nampak gaya dia, kamu boleh dapat tak? Itu saja. Okay, dalam masa tak sampai 5 minit. Silakan. Jot down on your blank paper. Can you list down all the elements in A times B and also B times A times B? Kalau kamu dapat buat tanpa repetitions, tanpa duplicate, then you berjaya lah. Bila dah siap, boleh tangkap gambar. Saya check seimbang selalu. Dan selalu paling cepat saya nak check ialah saya tengok jumlah dulu. Dia senang tapi senang silap. Macam mana nak cakap? Dia senang nak buat soalan Cartesian Product ni. Careless je yang masalah. So make sure for A times B, the first elements come from A, the second elements come from B. Do not duplicate it. For BAB, kalau BAB ni, kalau BAB ni, Yes. Okay, kalau ada soalan, confuse boleh tanya sekarang lah. Saya tak tahu kenapa ini nota yang saya buat dulu ni dia tak ada example. Dulu saya dah tambah example ni. Saya kena check balik. Yang bahayanya dekat bahagian ni je, benda baru Cartesian Product and Power Set. Kalau yang macam A union B, A intercept B tu and complement, I don't think you should have a hard time on that. Kalau dah dapat, bagi tahu saya pening nak tengok. Post dalam DMS Oh, ada dah? Belum. Korang okey ke? Senyap je ni. Risau saya.
Panjang.
Ada 54 elemen je.
Panjang sangat.
Panjang sangat. Okey, tak apa. Boleh saya tahu A dengan tunjuk A kali B je tak? Cartesian Product A times B je. Cukup lah. Ada 55 Sekejap. Banyak lah. 6 kali 3 kali 3. 6 kali 3, 18 kali 3. Dalam 54. 54 Musin. 6 kali 3, 18 kali 3. Okey, junjuk A kali B je. A kali B ada 18. Okey. Thank you. Siapa? Sekejap. Hafiz Ashraf, thank you. Sekejap. Is this misleading? Apa ni? Okay, Yang Teman berkata, is this misleading? No, it's not misleading. It's incomplete. Itu je. Saya tahu panjang, Teman. Mungkin soalan ni tak sesuai lah, tapi saya nak tengok idea saja. Apa yang Teman letak ni, 313, 613, okay. It shows that you are on the right direction. Teman. It's not misleading, maybe it's incomplete lah kalau saya tanya soalan ni betul-betul. Saya faham banyak. A kali B betul for Tengman, very easy, right? And siapa ni? Hafiz Ashraf betul. Hafiz Hakimi betul kan? Senang kan? Saya kena kira cukup tak? 1, 2, 3, 4, 5, 6, 7, 8, 9 kali 2. Okay, tak ada yang berulang. Tengman pun 3 kali 6, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. Dan betul, okay? Okay, cukup. Thank you Aiman juga, thank you Farhad dan juga Aisyah. Soalan A times B. Oi, dia siap B times A times B. Oh, tak siap lagi, tapi on the way 3, 1, 3, 3, 2, 3, 3, 3, 3, 3, 4, 3, 3, 5, 3. Okay. Saya rasa based on beberapa jawapan kamu ni, some of you, I think you already understand the concept of the ordered pairs or ordered triplets. Dalam kurungan bracket tu mesti dalam order ya. Make sure you have the complete amount of the not repeated elements in your Cartesian product. Itu saja yang saya minta. Soalan set lah antara yang saya paling malas nak semak. Oh, Arisa dia tak okay, Arisa letak bracket, curly bracket last tu je kat kanan. Lepas tu settle. Akram tidak mahu mengalah di sini. Rajin lah korang. I like. Untuk soalan set, antara soalan yang saya tidak suka semak sebab saya kena check satu-satu. Logik pun sama lah. Saya kena semak satu-satu kalau korang tak ikut susunan. Ada yang tak ikut susunan lagi nakal lah korang ni. Saya kena check satu-satu balik. Kalau boleh kurangkanlah sebab lambat lah nanti saya nak marking. Alright, I shall proceed. Saya harap Cartesian Product senang je. Jarang orang buat silap kecuali, again, careless. Alamak, putus lagi. Sekejap, mana dia detect ni? Sekejap setting, sini, reset. Okay, sini. I'm using ellipses to abstract out. Terpulang? Boleh. But if the element requires to mention all the elements, so it should be. Okay, let me finish today's lecture with the concept of power set, if I may. Lepas tu kita cukuplah power set. Function, nanti saya tanya round up kalau ada masalah. Function saya akan teruskan Selasa depan, tak sempat dah nampaknya. Dan saya pun ada letakkan dalam playlist DMS dalam YouTube saya, ialah pasal relation. Relation kamu kena hati-hati. Relation memang saya kena concentrate minggu depan for a complete 1 hour. Hari Selasa kita akan ada lecture, saya tak akan biarkan self study dulu. Sebab relation selalu student pening. Function tak pening. Function dia okay. But relation bahaya. So Selasa depan kita fokus kepada relation. Selasa depan Okay, kita teruskan dengan konsep power set. Okay, you already know about the Cartesian product, but power set is a little bit different. You already, if you want to master power set, you must master the concept of subset. Subset, A subset B. It means that all elements in A should be in B. Then A subset kepada B. Alright. Paling simple lah dia punya layman term. Tak betul ni. All element in A is in B. Pun tak betul dalam matematik, tapi tak apa. The idea is like that. Okay, katakan saya ada satu A and B. You can quickly verify that A is a subset of B. You are very fast to verify that. The thing about the power set is that how many elements like A that should be in B. PB or power set is the set that contains all possible subset of B. You see? Kita tahu A adalah subset of B. Subset. However, how many possible subset of B that can be in B? Okay, let me show you what I meant. This one, you tahu dengan pantas bahawa ni dalam 2, 1, 3. But this is not the only possible subset of B. There are more. Okay, so power set of B entitles all of you to mention how many possible subset that can be derived from B. Okay. So before you start that, the thing that very important for you to know is that the number of possible subset or the cardinality of PB is given by this simple formula of exponential of 2n. 2 to the power of n. N is the number of element in B. Okay. For this particular example, B is given as 2, 1, 3. The number of element inside B or the cardinality of B is 3. So the number of possible subset that can be made from B is 2 to the power of 3. You should have 8 possible distinct subsets. Okay, saya buka besar dulu. Okay. So right now, I should know that the power of B, if I need to find the PB, find PB. Based on the previous example, properties of subset kat sini, ini empty set is a subset for any set, and the set itself is a subset of itself. Okay, so I always advise my student, but you are not obliged to follow that, is that you should have an empty set. Mesti ada. And you should have itself 2, 1, 3 based on that property. Because empty set is a subset for B and B is also a subset of B. What comes next is just a derivation of the combination, I suppose. Saya boleh keluarkan 2, 1, 3. And also I will open 2, 1 and 2, 3. I should have one more, suppose, which is 1, 3. The concept that I use is the combination. Combination C tu, bukan permutation. Permutation bahaya you nak guna kat sini. Sebab elemen kat dalam set might not be in order. Combination, order tidak memberi perbezaan. So, kira balik. 1, 2, 3, 4, 5, 6, 7, 8. All these sets are different. Okay, all these sets are different. Empty set 2, 1, 3, ulang 2, 1, 3, 2, 1, 2, 3 and 1, 3. All of these are possible subsets of B. The dangerous thing that some of the students did is that they write multiple set. Digunakan konsep permutation tadi tu. Okay, for example, 1, 3, 2, dia tak salah lagi. Yang salah kat sini nanti. If they write 2, 1 and they write 1, 2 and then they finish with 1, 3. They count it 8 as well. The dangerous thing is that they don't realize here 2, 1 and 1, 2 is the same set. So when you actually count for the red color part, it's only 7. Because again, I repeat, 2, 1 dengan 1, 2 ni is the same set. The thing that they left out is 2, 3. Ada yang tak nampak tak kesalahan kat sini? Boleh nyatakan. If some of you cannot see the mistakes here, voice out lah. Ke ada yang WhatsApp ni? Tak ada. So make sure when you want to derive the subset, make sure you don't have the duplicate set. This time, although the order in the element is not the same, but actually is the same set. Hati-hati kat sini. So this is incomplete. Okay, ada soalan setakat ini sebelum pergi kepada soalan. Okay, if you know, don't have a question, let me test you a very simple one.
Alah, putus lagi. Biarlah. Okay, given B equals to 2, 3, 5, 7, find power set of B. Sekejap. Tak detect.
Okay. Sekejap cuba tengok ni. B is 2357, find PB, itu je. Okay, I will do it together with you because we have only around 10 minutes left. Okay, how many possible subsets that can be made? So I always do that as my reference first. It will be 2 to the power of 4. It will be 16 possible subsets. You might always start with a fundamental one, which is this, empty set and also itself. Then you, by using combination, you derive one by one. You can start first by the single element, 1, 2, 3, 4, 5, 6. Saya bawa ada 6. Okay, I finish the single, then I proceed with the double. 2, 3, 2, 5, 2, 7, 3, 5, 3, 7, 5, 7. Okay, saya ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ada 4 lagi. Okay. As for now, I don't have repeated sets. Okay. Then what's left is the combination of three elements: 2, 3, 5, 2, 3, 7, 2, 5, 7. Two, three, five, 2, 3, 7, 2, 5, 7. Saya ada satu lagi.
5, 7.
Thank you, Muslim. 3, 5, 7. Tutup kurungan besar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Make sure it's not repeated, then I finish. So this is just a simple application of combination. This quite intuitive lah. Saya tak jumpa orang kata cara lain melainkan combination. Student jangan lupa ya, from the properties. Saya selalu advise diorang mulakan dengan tu dulu. Itu paling kadang-kadang student lupa. Okay. Tak perlu tunjuk jawapan, kita dah bincang jawapan kat sini. Right. Saya saja nak tunjuk soalan Dr. Syam ni yang sedikit pening. Okay. Yang nombor example 2 ni lah. Example 3 actually. Okay, ni saya tengok seimbang dulu. Nanti saya padam tengok. Nanti tengok recording. Alright. Nah, ni untuk saya bincang saja. Okay, determine the power set of empty set because the empty set has no elements. So it will be only one, which is itself. Okay, which is itself. However, this is not empty set. Okay, suppose A contains of this empty set and a set which contains empty set symbol. Okay. So, it's a good practice for you to know what is the number of element in this power set A. Is there are 2 elements, it will be 4. Betul. And the confusing part comes later, but worry not. Okay. We always start with the empty set properties, which does not come from this A. Dia datang dari empty set. And also itself. Itself apa? Ambil keseluruhan yang atas ni, turun bawah. All of it. We have 2. Next, this set and also tutup kurungan. Okay. This is Dr. Syam's question. Adalah yang saya kena baiki kat sini. Okay. So yang slide ni sama-sama kami buat. So kami tak dapat check lagi. Saya tak suka soalan macam ni. Tapi nak bagi student confuse boleh lah. Okay. Do you have any possible question for the subset? Hari ni kita belajar 2 benda yang agak major, which is Cartesian and also the power set. Okay, hari Selasa kita akan buat lagi soalan. Saya ada buat tutorial dulu, tapi tak sempat habis. Saya akan check balik dalam kalam tu, saya share balik dalam Google Classroom. As for now, tomorrow you will have your test for linear algebra. So I wish you all good luck. Semoga boleh jawab soalan linear algebra. Saya tahu ramai yang bertanya soalan tadi. Dr. Saimi bagus. Dia akan jawab soalan student dengan satu-satu. Dia memang bagus. So good luck lah untuk besok. Next week korang ada quiz assignment apa semua. Spend your time wisely. Arrange your time very wisely. Try to minimize your commitment, personal commitment. Try. Saya faham. Ada yang ada mak bapak suruh buat kerja apa semua. Ada yang adik-beradik minta tolong apa semua. Try to establish your learning time very well. Ada soalan tak berkenaan pembelajaran hari ini sebelum saya tutup? Saya check kalau ada. Apa ni? Really, sum of combination is equal to. Pasang lagu tak sempat lah Arif, sorry. Tak sempat. Next time saya pasang. I don't have any comment. I'm not sure what do you mean by weird. Yeah, it may be weird for you. Maybe we can prove it. But I don't ask you to do that. You can think on your own. Maybe perhaps one day we will find the answer why the sum of combination is equal to the power of n. It's good to think. Oh ya, saya nak 1 minit untuk cakap benda ni kepada semua student. Saya cuba pendek, sabar ya. Ini bukan pasal pembelajaran dah. Kalau ada soalan tak? Kalau tak ada soalan, saya nak cakap apa yang isi penting saya. Isi penting saya ialah there's a principle in philosophy mentioned by the old Greek philosopher named Occam. And Occam states that the best explanation is the simplest. Kalau saya tahu ni daripada satu drama, saya tengok drama tu, House MD, and House MD told me about the Occam's razor. Yes, Occam's razor. Imran Khairul tahu ke? Occam, or OCCAM. And Occam's razor also has been applied in the film of Hindustan, Three Idiots. Saya tak tengok, saya tak suka tengok Hindustan. Tetapi Three Idiots saya tengok. Three Idiots says that sometimes the best explanation is the simplest. So I try to adopt this in my teaching, and also I hope for you guys as well. When you try to explain something, okay, for example, macam dalam filem Three Idiots tu kan, kalau you all tengok, what is a machine? A definition of a machine, kalau dalam fizik apa semua, dia memang kompleks. Machine is something blah 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 blah, and then hero in that film says a machine is something that they try to explain is a very simple layman term. Dia ada kelemahan dalam Occam's razor dan ada kelebihan juga. Kelebihan dia sebagai seorang pendidik, okay, as an educator, I teach from a school level until you guys punya level. School punya level lagi, kalau saya nak cerita pasal prime number, macam mana saya nak explain prime number? Kalau saya nak explain kepada student yang lemah dan juga student level rendah, susah sebenarnya. Prime number saya kalau nak kompleks saya boleh cakap. Prime number is defined as the number which the only factor is itself and also 1. Seems simple for you guys, betul? Tetapi ada student dia kalau sekolah dia tak faham. Saya kena bagi contoh. So dalam cara saya untuk kenapa bila saya ajar method 1, method 2 tu adalah hasil ada setengah student dia tak faham explanation pertama, that's why saya explain yang kedua. Kalau tak faham lagi, ada student tak faham lagi, saya kena fikir lagi cara paling senang. So back to Occam's razor. When you try to explain or teach your friend kepada kawan, macam contoh Mohsin ni lah, saya tengok dia kadang-kadang dia bagus, dia bukan saya nak puji dia lah, kawan lain pun ada yang macam tu. Dia cuba explain, try to explain to accommodate the readers. Adalah point saya nak cakap sini, harap faham lah. Ada setengah kawan kita tak faham dengan cara awak, jangan give up, kita kena ubah kepada cara lain. Make sure dia orang betul-betul faham. tak semestinya explanation kepada kita tu adalah yang terbaik. Kita memanglah faham. Kita faham cara kita. Orang lain cara faham orang lain. Untuk ekonomi 62 orang kat sini, saya kena cari jalan yang mudah supaya semua faham. Dan even itu pun saya risau ada yang student tak faham. Saya sarankan kamu, yes, the best explanation is always the simplest, and I think I heard this somewhere, I read this somewhere. There are quote that keep it simple, comma, stupid. Saya pernah baca kat mana. People try to overcomplicate things. That doesn't matter if people can understand. Try to simplify things. It makes my some of the life easier. Although some of the information is not complete. Okay, sekian sahaja falsafah hari ni. Korang dah tak ambil falsafah kan? Okay, saya ajar falsafah. Alright, tak ada apa dah untuk saya ni. Harap kamu dapat ambil lah apa. Ambil benda. Okay, falsafah. Oh, ambil. Siapa ajar falsafah? Oh, bosan betul lah falsafah. Falsafah tu bosan. Matematik membosan. Tak apa, layan je. Okay, soon memang bosan. But that's the spirit we layan je. Okay. Nice to have you guys as my student. I hope to see you again next Tuesday. And while waiting for get ready for your test, for other tests. Okay. See you then. Bye. Assalamualaikum. And goodbye. Stop recording.